talking about thermometers today, and I have one you guys can pass around so you can look at it. Look at it. There we go. Okay, so you've all seen thermometers before. Are you whispering? Can you? Okay. But what does the thermometer measure? And here are your hints. Yes.
Heat.
Okay, why does it measure heat?
Because that's what we've been learning about.
So what is heat then?
Things moving, like tiny particle things moving.
It's a temperature.
What's the difference between heat and temperature then?
Temperature's how hot it is outside.
Heat is a type of temperature, but temperature is not a type of heat.
Okay. So if I have one ice cube in one hand and two ice cubes in the other hand, do they have the same temperature?
2 ice cubes, you said?
Yeah, one ice cube and two ice cubes. Do they have the same temperature? If I put a thermometer on them, they're going to stay the same. But do they have the same amount of heat?
Yes. No.
Okay, why not?
Because there's 2 of them?
So why does having two of them make a difference for for heat and not for temperature?
Because they're twice as cold? No.
Okay, so can we have
no
heat in an object?
Yes. Would there be no heat in ice?
No. There's not no heat in ice.
But it's cold.
It is cold, but it's not as cold as it could be. So the particles in ice are moving, and the movement of these particles we call heat. So, what is heat that temperature isn't then? So what is the difference between the two? Like if you could say in one word what heat is and what temperature is.
Have we learned what temperature is?
Yeah, we've talked about it.
Oh, we have. Oh.
A little bit, yeah.
Heat is the amount of movement of the particles?
Okay, so, and then what's temperature? That's not the same thing.
It kind of tells us if there's a lot or not a lot of heat in something.
Okay, so the word that we used to describe heat was total. So for the whole, so what would be a word that we could use to describe temperature?
Would it be the part of?
Okay, it's like a part of.
Average?
Average. Okay. So we said our thermometer measures temperature, right? But how? So what's happening in the thermometer that allows it to measure temperature? What changes?
Is it being heated up?
Yeah, so the heat in the thermometer is changing. Yes. And so that has an effect on the particles. So we talked before about how adding more heat to a particle makes it move faster, taking away heat makes it move slower. So how does that affect the thermometer? So what do we see when the heat goes up?
The thermometer goes up.
So what happens to like the volume of liquid?
It gets bigger.
Okay. Okay. So when you add heat to a substance, it expands, and when you subtract heat from a substance, it contracts, because the particles, when they're moving faster, take up more space. So in a thermometer, we see this because when the temperature goes up, we see more, we can see more of the liquid, and we measure that on the thermometer. Okay. So, do you guys think that we would be able to make a thermometer out of these things? Based on what we know about how things react to heat.
Will something that you have get bigger or smaller when it's like hot and cold?
Well, do you see anything that could get bigger or smaller? We have a jar of water. We have
Jar
some
could get bigger.
Have you ever seen a jar get bigger though?
Yeah.
Okay. Do you see anything else that might get bigger or smaller?
The water in the jar.
Yeah, so just like the liquid in the thermometer, the water in the jar changes based on the temperature. So we're gonna use these things. We're gonna hopefully I can do this. This is kind of hard.
So what are you doing there?
Okay, we're just creating a seal so the water can't get out. And it has to go in the straw. Okay, what color do you guys want it to be? We have colors. You can pick. Yellow, maybe no.
Purple.
I like blue.
Blue? We already have a blue one. We have another one. Do you want to do a different color than blue?
Let's make it red.
Red?
Yeah, like a thermometer.
Yeah. Let's, you have to.
Oh, it's going. It's just slow. Okay. Okay. So, just like a thermometer, we can make marks on this to measure what different temperatures are. And I didn't bring a marker with me. Sorry. Oh no, I can use these. Yes. Okay. So this is where the water sits when we're at room temperature. And I have cooking show magic. I made one already. Whoosh. So, yeah, food colors just so that we can see where it is. So, what do you guys think is going to happen if we try to heat them up? Is the water going to go higher or lower or stay the same?
It's gonna go up.
Okay, you guys want to try? 2 groups 2.
Like with our hands?
Yeah, you can use whatever you want. Try and make it go up.
Get the blowtorch.
Don't use a blowtorch, please. Be safe.
I'm not seeing any movement yet.
That one's hard because I think it might have gone down after I... Yeah. Now you guys can use your observation sheets to write down what you
Increase my
noticed.
surface area. I'm really having a hard time.
So just like with a regular thermometer, you're going to notice that they move very slowly because it takes a long time for the heat of the water to change.
Oh, whoa, it suddenly jumped.
Did you push on the clay?
Oh, I guess it did.
So you pushed the clay into the jar, that's why it jumped.
Oh, it looked like it might have been leaking a little.
That's what happens.
Right now it's going down.
Now it's definitely leaking.
Now it's definitely leaking.
Here.
Oh my gosh, that's food coloring. Okay.
Are you okay? Sorry. Are you okay?
Am I okay? Yeah, I might have slightly more purple pants.
Experience strong.
Oh, yay.
Did your guys go up?
A little bit.
See? Works. I know that one works, so I tried it. Okay, so is there another way that we can make the water move?
We
Based
could
on-
cool it down
Yeah.
with the ice.
So,
Put ice in it.
I'll put ice in it. Ice on it. We can't put anything else in it. The thermometer is done. It's the way it will be now. Okay, so does anyone have their observation sheet done? And they want to share what they have?
I covered my thermometer with my hands, and I saw the heat or the water rise above the line
Okay, so why did that happen?
because the particles started moving faster, and then they shot the water up the straw.
Okay. Does anyone else have an explanation as to why that would happen?
Heated up, the water expanded.
Very good. Okay, so what did you guys see when you cooled it down for you guys? Did it do anything yet?
It went down a little.
Mine went down a lot.
Yes. Model student. Okay, why did it go down? Anyone? It doesn't have to be. Anyone can answer.
Well, if the heat made the water expand, maybe the cold made it contract.
Yeah, so the particles are moving less quickly, so they don't occupy as much space. Okay, so we have this experiment that we did, but can you guys think of any ideas for if we did it next time, how we could make it better?
You could use a blowtorch to heat up the
That is dangerous. And also, wouldn't the water just evaporate?
Well, what if we put a stopper on top then? What if we put clay on top of the straw?
Can anyone think of a safe reason in that way that we could improve this experiment? What might be a way that we would see it move more?
Maybe something that not water, something that moves, that gets bigger and smaller, with small changes.
Okay, so having a different liquid in the thermometer. Does anyone else have anything that we could change? Because these are fairly small jars, so when you guys heated up your water, there wasn't a lot of water to move. So what could we do?
If we had a smaller jar.
Would that make more or less movement?
What if you had a really big jar, and then would it shoot it up more?
Now, I think a smaller jar would be good because then you could heat it all up faster.
That's true, but it would move less overall, but it would move more quickly.
Yeah.
Okay.
A smaller straw?
A thinner straw? Then we
Yeah.
would see more difference? Yeah? What about if the jar were made of something different? Do you think that this would work really well if the jar was made out of something that the heat from our hands couldn't get to the liquid?
No,
Yes.
it wouldn't work.
Then it wouldn't work.
So we wouldn't see any movement if the heat from our hands couldn't get to the jar or the cold from the ice. But would we see more movement if the jar were made from something where more heat could get through?
Yeah.
Thanks, guys.
Thank you, Professor.